Okay, that's fine. All right. So how did part 1 do for you guys?
It was fine.
Not too bad?
Nope.
Not too bad,
Yeah.
no.
Well, the only thing though I forgot, and I wrote down in the notes is where do we get the P, not the P hat, but the P from? And I wrote in the notes, P hat is equal to x1 plus x2, but I'm thinking that's supposed to be P over n1 plus n2.
That's P hat.
That is how you get P hat.
P is whatever's given, like if they give that to you.
Okay.
That's what you're messing with. That's what in the question.
So P hat is what again?
Your P hat is it's the like for P hat for 1 is x1 divided by n1, and then P hat for 2 is, or P hat 2 is x2 divided by n2.
Okay.
Okay, so well, this is where I think I may have made a mistake in my notes, because I wrote P hat is equal to x1 plus x2 over n1 plus n2.
That's for the whole sample proportion, for all of it. That's for when you're looking at the entire sample, not the divisions of the sample.
Okay.
Not the same. Okay.
So in the one, the number 4, I know we haven't figured it out here. So where would the P be? What would be P?
Well, we're not worried. We're going to use the P hat for this because we have 2 different samples we're dealing with.
So because I'm just trying to figure out, because how you compute the test statistics that is z, z equals P hat 1 minus P hat 2 minus P1 minus P2. I guess that's where I'm confused.
Well, what I did is I plugged it into that Excel worksheet.
Yeah, I did too, and that's wonderful. I don't know why I didn't do that the last lesson.
No. I'm like, oh my gosh, plug it in and boom, it's done.
Yeah. Yeah, it's a lot easier.
But that's how I mean, because that was the same thing. I'm like, okay, but what's the difference between P and P hat? But at the same time, when it came down to it, if I plug it in, I'm like, does it matter? Because sometimes they are the same.
Yeah. Okay. Yeah, I don't know. On the answer key for the homework, it says, oh no, it doesn't say what P is.
Because you only have to deal with P if it's given, I think.
Okay.
Okay, can I ask you? I actually do have one question. So you have to do the requirements, right? You have to make sure that's greater than 10. I can't find my paper that I wrote that down on to actually write down. But then you have to do that where it's greater than 10, and then the P minus 1 is also greater than 10?
N times P is greater than or equal to 10, and then N times 1 minus P is greater than or equal to 10.
Say the second part again.
N times 1 minus P is greater than or equal to 10.
1 minus P is greater than 10, or equal to 10. And then, but there's 2, the requirements, when you have 2.
When there's 2, so that implies, so you have to use the P1, N1 for the first line, for the first 2, and then you have to use the P2 and N2 for the second 2. And you do it for both sample sets.
Okay. So I got the first part, the N times P. Well, 296. Well, anyways, I'm jumping ahead to the actual assignment, so we'll get to it in a minute. I'll stay.
Well, that's fine.
Because I was trying to do 4A, and anyways, we can let's not waste time on that. Let's just go through it. Actually, that is the first thing to do pretty much. But
the first one.
Well, is it P or is it P hat? That's my question.
Huh?
Is it P or is it the P hat?
Well, it's the P1 and then P2, and then P hat is, you're going to do P hat 1 and P hat 2 for this.
Well, P hat is P1, right? No.
Yeah.
No.
Well, for this is, the P hat for the entire problem is different than the P hat 1 and P hat 2. But P hat 1 and P hat 2 are just the combined values of both samples.
And when you're checking requirements, you're going to use the P hat.
You have to do each sample individually because you have two different samples. You got to make sure each sample is meeting the
requirements. Okay.
Because if one doesn't meet the requirements, but you add them together because the first one has so many and the second one doesn't have enough, but you add them together, it averages out to look like it's normal, but one of those samples isn't normal. It's not high enough. Does that make sense?
If it's not high enough, it doesn't meet the requirements, then you can't even do the test anyways, right?
Yeah. So you test each sample independently to do that.
Okay.
So so for number 2 on the front, when it was telling you what the p hat was the overall proportion, that's for the bottom. That's for the standard deviation of the two together.
For Z?
When you do the number 2 on the front, on the first
part 1,
to do the z-score, when it tells you when it has the p hat, what is the overall sample, which is the x1 plus x2 over n1 plus n2, that is for doing the standard deviation.
And standard deviation is the it's not the z-score. What is it again?
What?
How do you get the and then where do you use the standard deviation? Anyways,
Well,
I don't even know what I'm trying to say.
Well, we're not really using the standard deviation. That's just what that formula is.
Yeah.
So
Okay.
I haven't seen how we've used that really here.
So yeah, for the requirements, I don't know whether I was just confused, but I have that it's like the P hat for both of the samples, for N1 and N2.
They're p hat, but they are it's the p hat of the first sample and the p hat of the second sample, not the overall.
Yeah, I have P hat 1, P hat 2.
Mm-hmm.
Yeah, that's what I have too. The
Okay.
P is not even in the equation.
Yeah, it doesn't even come into this one.
Okay, awesome. Thanks.
Mm-hmm. Okay, so for number 4A, we all okay?
Yep.
Yeah.
Okay, so it would be 296 times 0.213. Was 63, which is greater than or equal to 10, and then you do the 296 times 1 minus 0.213, gives you 233, which is also greater than or equal to 10. So the first sample is good. The second sample is 251 times 0.108 equals 27, which is greater than or equal to 10, and then the 251 times 1 minus 0.108 equals 224, which is also greater than or equal to 10. So they're both requirements are met.
That's what I got.
Remind me though, how do they get the 0.213?
That is the x divided by the n. So the
Yeah.
divided by the sample size will give you the p hat. And the beauty of this wonderful, fantabulous little Excel worksheet, you just plug it all in and all the numbers are there.
Yeah.
What I
I
did.
didn't even do the calculations. I said that on the.
Yeah. Well, I wrote them down just so I could see them when I looked back at them, but I went and looked here to double check all my math.
Oh, okay.
But 63. How come my p hat, like I typed in everything into the computer, but my p hat for P1, maybe I typed in the numbers wrong. And the inputs, did you put like 60? Do you have your Excel thing pulled up?
I'm putting it in right now. Hold on. Um, okay, now what's your question?
So, and then do you do the type of test is P1 is not equal to P2? Is that the test you did? But I typed in, so the numbers I typed in are 63, 233, 27, 224.
No, N1 is not right.
N1, N1 is 63. No, sorry, X1 is 63. N1 is 296. X2 is 27.
Oh, but I thought the guy in the video, I thought he did the math. I thought he minused it and did that.
That's when you're plugging in the data in the SPSS to do the bar chart.
Oh, got it. Okay.
So that's the N is the total population or the sample size.
Yeah. I understand. That's why I was mixed up because I'm like, my p-hats are different than what the answer key is telling me. That would make a difference, of course. So, okay.
Okay. So once you plug all that stuff in, then you get for your. So we got all those numbers for A. So for B, the null and alternative hypotheses.
Yeah,
not
equal to.
Yeah, the alternative is not equal. The test statistic is given on the little formula thing. It's 3.309. P-value is 0.001. This thing is awesome.
I know.
And then you can go in and plug all that into the distribution curve on the applet and to look at it. And it's just out there. It's pretty easy. You gotta sketch that or copy and paste it in so that you can get a visual of what you're looking at. And then, you guys want to do them? I don't have to do them all. I don't know what's going on. I just, sorry.
I can if you want to. I don't care.
We're all looking at the same thing. So.
Okay, so we're going Stephanie, Patty, Brianna, then Stephanie, and then me.
All right, go for it, Brianna.
Okay. So G, right? Or F?
F.
I said reject the null.
Yep. That's what I've got.
Because the P is low.
Yep. You got it.
Okay, G. So in layman's terms, you have to start out, we have sufficient evidence to say that there is a difference in the proportions of who uses the labels, the men or the women. So, yeah, in the proportions of men who use labels and women who use labels.
That's what I got.
Yep, me too.
I believe
that. Number 5, I just used what the output was from the Excel at 0.045 and 0.166.
Yep.
Okay.
Okay, and then to interpret it, it's we are 95% confident that the true difference in the proportion of men using labels and women using labels is between 0.045 and 0.166.
Yep.
Easy.
All right, let's go
really quick. So because that 0 is not in that interval, is that another reason why? What does that mean if 0 is not in that confidence interval? Then what does that mean again?
Not in the confidence interval, then you can actually deduce there's a difference. If 0 is in the confidence interval, you can't because it's not. You can't tell if it's higher or lower. Because it could still be 0 means they're the same. If it's higher, if it goes on either side of 0, then you can't tell, is it the same or is it different? Is it somewhere in there? So if 0 is in the confidence interval, then you can't tell if it's different.
So if 0 is in the interval, then there's insufficient evidence of whatever you're trying to figure out.
Sure.
Okay.
Okay.
I can hear myself echo in one of your guys' computers, like it's a half a second delayed or something.
Weird.
I'll turn my volume down. I don't know if it's me.
I just started on Plango, so I'm hearing myself. I'm like, what?
I don't know. All right, let's go and start. I have a client at 11:15, so we need to do this, and then we need to talk about our design the study. We'll see you tomorrow.
Okay.
Here we go.
What time do you have a client at?
11:15, and he's new, so I need to make sure. I mean, I already set up my room, so that's ready to go, but I need to not be like, hold on just a second, let me finish up my.
I don't want to be scatterbrained. I understand.
No, it looks really, really bad. It's very unprofessional. But we should be fine. Okay, so for number 3. Equals 7.
Is it my who went last? I remember. Oh, did I just go? I just went.
It's Brianna next.
Okay. So for 3 out of 70 females in a sample, 52 can taste PTC. Out of 59 males in the sample, 42 can taste PTC. So let P1 be the proportion of females in the population who can taste PTC, and P2 be the proportion of males in the population who can taste PTC. The research question for the study is given here: is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? So in our handy dandy worksheet, we'll put 52 and 70 and 42 and 59. And then it is different from, so not equal to.
Mm-hmm.
And so for P hat 1, I got 0.743.
That's what I got.
Oh wait, no, it says P1 is the proportion of females. Oh yeah, okay.
So yeah, P hat 1 is 0.743.
Okay.
Hold on, I'm putting my numbers in.
Okay.
You said 0.743, right?
Yes.
Okay.
Yeah, 0.7. Okay, I agree.
Carolyn, who's after Brianna again? Will you?
Oh, you.
Me? Okay. Thank you. Okay, so for P2, I got 0.712.
Mm-hmm.
P hat 2, I should say.
Yep.
Oh, well, what did I? Oh, because I wrote the same. I got 1 because I put 42 in both places. Okay.
Okay.
42.
Okay.
Oh, okay.
Did you figure out what you did?
Yeah, I put 42 in both places instead of 49 and 59.
Gotcha.
Okay, so the hypothesis for this one, because it wants to know if it's different, would be number 2. The alternative would be P hat 1 is not equal to P hat 2.
Yep.
I think it's actually P1 and P2 because it's telling us in the sample thing, or in the information it says P1 be the proportion of females that can taste it, and P2 is the proportion of males. For the research study, the proportion is different.
I actually agree. That's what I have written
I
down.
think it's P, not P hat.
I clicked the last one too, but truthfully it was because I just was looking for not equal to. I just clicked that one, but because P hat would be the sample proportion is not equal to the other sample proportion, so you want the complete proportion, right? So that's why it's the last one?
Mm-hmm.
Okay.
That makes sense. That was good reasoning, Stephanie. Because I didn't understand why. I'm like, okay, I guess.
Almost better.
Because using a hypothesis, you're dealing with typically you're dealing with the P, not the P hat.
Yeah.
Okay.
Okay.
Yeah, when I look at my notes, that's for the hypothesis testing. It's P1 not equal to P2, not P2.
Yeah, that's what I usually see in the videos too.
Mm-hmm.
Okay.
Well, I gotta minimize things so I can see everything at once here.
I was gonna load up the quiz on this laptop instead of my desktop, and then I was like, oh crap, I already opened it on this one. So then that way I'm not looking all the butt.
Yeah.
Talk about, because I've already minimized you guys over here, but it's too late. I didn't do it fast enough.
Okay, so for an interval for P1 minus P2, Is that in here, or do we have to take that in and do the difference?
No, I.
Oh, wait, it's already figured
It's
out
in
on that
Excel.
same thing.
Oh no, it's right here. It says that P1 minus P2. This is the interval that's in here. It's already set at 95%. So it's negative 0.123 and 0.185.
Yeah, the second one.
Yes. Sorry, my brain went somewhere else there.
Okay.
We're good. So there's that.
Is it my turn?
I think so.
I forget if I'm after Brianna
Yeah,
or before Brianna.
Brianna's next.
Okay, so I'm always after Brianna.
With alpha being 0.05, what decision do you make? And I think we failed to reject the null hypothesis, right?
Right, because our p-value is 0.693.
Okay.
So yeah, so you failed to reject.
Okay, Stephanie.
Which of the following statements best describes the outcome of this study? Can I just read it myself, or do you guys want me to read all that?
You can read it to yourself.
Okay, which of the following statements best describes the outcome of this study? I'll just read them. There is sufficient evidence to suggest that the true proportion of females who can taste PTC is greater than the true proportion of males who can taste PTC. There is insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males. There's insufficient evidence. I got to read it to myself because if I read it out loud, I'm not paying attention.
Don't worry about reading all of them. Just
yeah.
tell us which one you think it is.
Insufficient. So it'd be the second one, right?
It's insufficient and it's different, which is what we're looking for.
Yeah, not less than. Okay. I think it's B.
I agree.
All right.
Okay, for questions 9 through 17, we will review the mortality rates and day of admission heart attack study with different data. Out of 118,519 who died of a heart attack during a weekday, 16,713 had died, or who had a heart attack, that many died. So out of 42,447 that had a heart attack on the weekend, 6,155 died. Let P1 be the proportion of patients who had a heart attack and were admitted on a weekday who died, and let P2 be the proportion of patients who had a heart attack and were admitted on a weekend who died. The research question for this study is given here. Is the proportion of patients who have a heart attack and admitted to the hospital on a weekday who died less than the proportion of patients who have a heart attack and are admitted to the hospital on a weekend who died? Use a level of significance. The conditions for hypothesis testing are satisfied, true or false. So the conditions are the same. We have to calculate the P1 and the P2 value.
Yeah, so we gotta go ahead and plug everything in, and it'll tell us if it's met or not.
Oh, it does?
Well, it tells you what the numbers are for this, so you don't have to do the math.
Really?
On the check requirements on the Excel thing to the
my
right.
Yeah.
Pretty fancy, huh?
What?
So P1 is weekday. I gotta write it down so then I can move it over.
I think it's sweet.
I know, right? Whoever programmed this is amazing, I'm telling you.
I kept checking them when I first did it. I kept doing them longhand, and I'm like, this is taking forever.
Didn't even know they did it, so I definitely did it longhand.
My phone keeps blowing up.
Wait, you know what? This is the thing that's so weird. Is when he was showing us the video on his Excel thing, there was like a he had the input information and like all the different, you know, P's and the Z and the confidence interval, but then on the check requirements, his like was longer because mine just has like where the first sample like the size of it, but it doesn't say, it doesn't like calculate it. Does that make sense? It's just like a short little box with 2 columns.
Yeah, it calculates it for you and just tells you.
No, it just typed in the number from the, wait, did you guys do the type of test is less than? Is that
Yeah.
would that change? But the check requirements, all it does is type in the size of the sample that I put in for X1 and N1 and X2 and N2. It just, well, never mind, it didn't do that.
Mine did, but the number for the first sample, I came out with the same number for the top.
Yeah, the first sample, and then the second sample is the X minus, or the, it's the subtracted amount, the difference, right?
Mm-hmm.
But then how do I know if it's greater than 10? Do I have to do the math myself and divide it? It's not showing,
Right,
can
so
you share your screen? Will you share your Excel screen, Patty, of when you typed in
yeah,
this?
mine's doing the same thing, exactly what you're saying, but I didn't notice it. Hold on.
It's not telling if it's greater than or less than 10. It's just having the samples, but it's different than the video that when he showed us how it did it and then he checked the requirements. It doesn't, yeah, see? And on the video, it doesn't show that right portion.
If you click on this, if you click on the cell, though, I think it's doing the right
Oh.
equation.
Yeah, it's multiplying them together.
Yeah.
Click, show me. You don't want to multiply them. Well, yeah, you do.
Yeah, you do. So if you look up here, look in the cell. It's got, if I click on this top sample, it's got C5 times C16. So C5 is N1, and P hat 1 is 16. This is, if I click on the second one, it's C5, which is N1, times 1 minus C16, which is correct. So if you look at them, the formulas are correct.
And if I type it into my calculator, like the same thing, I get 16,711. So it's like 2 off.
But either way, it still meets the requirements.
Yeah. It's just super close.
Yeah, so I think we're okay.
Yeah,
Well, just think about it for just a minute. Because C5, where's C16?
C16 is the P hat 1.
Yeah.
So it's the same number? It's just such a small P hat that it doesn't really change that. Because if you look at it, C5 times C16 is 16,713. That's the same as the sample size, or as the whatever they figured out who died.
Yeah.
16,713.
I agree.
So that's why I was confused, because it had the exact same number, and I'm like, it must not be calculating anything.
Yeah.
Okay. But you're right. I see how it has the formula up there that they have it programmed. So
Yeah.
obviously they're all greater than 10
Yeah.
shot. So
Okay. All right,
So-
so who's that?
who was on 9? Oh, that
you're
was
up, Pat. You're up, Patty.
Okay, so which set of hypotheses is appropriate for addressing the research question? I think it's the first one, because isn't that what we're doing? Forgot what the question was.
Yeah, P hat is less than P, or I'm
Yeah,
P1
P1
is less than P2.
So yeah, so it's the first one.
It's the alternative.
Yep. And for 11, I got 0.141.
okay. For P hat 2, it's 0.145.
Mm-hmm.
Okay, hold on. Okay, and then the z-score is negative 2.020.
Mm-hmm.
Yep.
Then given the z-score from 13, which should you shade? The left or the right of the z-score for the p-value? You're going to shade the left because you want it to be less than.
Yep.
Yep.
Mm-hmm.
And yeah, the p-value is 0.022.
Yep. So we are going to, on 16, what is the decision? It would be reject the null.
Mm-hmm.
Okay.
Wait.
It's
If the
point.
p-value is greater than the level of significance, we fail to. So what did you say? We rejected the null?
Well,
Wait,
I
wait,
said reject
wait.
because if the p is low and it's less 0.022 is the level of significance 0.05.
So we're
Yeah.
rejecting the null, right? Is that what you said?
The bottom one, reject
Okay.
the null.
All right. At first I heard fail to reject the null. Okay.
Oh, sorry. I hope
That's
I didn't.
okay. No, that's not your fault. That's my fault. Okay.
I could have
I'm
very
gonna read
easily
this
said
to myself and then determine which one.
Carolyn, I think you're up.
Yeah, I'm reading them to myself
Oh,
because
sorry.
if I read them aloud, I'll get lost.
Yeah,
Totally.
that's fine too.
Okay. So I say it's A. There's sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than the proportion of patients who have a heart attack and are admitted on the hospital on the weekend.
That's the one I think is.
Sounds good.
Me too, me too.
You guys want to hurry and go through the answers really fast or submit?
Yeah, we can go through the answers.
Okay, I'll read it really fast.
Okay.
Let's see. 3 is 0.743. 4 is 0.712. 5 is the last one. Not the hat, not p hat, just p1 is equal to, and the alternative is p1 is not equal to p2. Number 6 is the second one, negative 0.123 and 0.185. 7 is fail to reject the null, the third one. 8 is the second one. There's insufficient evidence to suggest the true proportion of females is different. Number 9 is true. 10 is the first one, is less than. 11 is 0.141. 12 is 0.145. 13 is negative 2.020. 14 is to the left. 15 is 0.022. 16 is reject the null, and 17 is the first one.
Yep.
All right, I'm submitting it.
It's 100.
100.
Okay.
Oh. All right. So let's
Okay.
study. So now we get to design the study.
Okay, so did we have any
Do
other?
you want to stop recording, Carolyn or Patty?
I'll stop it.
I guess people don't want to.